Hello everyone, I'm LIKA, Sports Leader. Hello everyone, I'm SHIN, Sports Leader. As of today, COVID-19 has infected over 400 million people globally, and almost 6 million people had died from it. To deal with this pandemic, our world responded very quickly. In just 1 year, scientists and doctors had successfully developed a COVID-19 vaccine. Now, let's take a moment and take a look around. More than half of your classmates have already had their first vaccination. Some of you may have even completed the second injection. So today, we are going to talk to you about vaccines and the world's most brilliant spy, the virus. We say the virus is the world's most brilliant spy because it can break into the world's toughest defense mechanism, our immune system. Our immune system is a miraculous place. It can detect anything that is unknown to our body, such as germs, blood, and bacteria. And when that happens, it will reject them right away. So if our immune system will attack any invader, how in the world can the virus still infect our body? This is because the virus is the world's most brilliant spy. Now, let's take one of the flu viruses for example. So, we have a healthy cell over here. Around the cell, there are receptors, which are acting like the locks. Only authorized people can enter. Then, we have the nucleus over here. It is the core of the cell. Now, we have the virus over here. The shell of the virus is made of protein. Around the virus, there are some spiky things. Inside of the virus, there's the core of the virus. When the virus reaches the cell, the spiky things will trick the receptors to open and let it in, just like opening a door with a key. And this will be the first time that the virus tricks us. It made us help the virus enter the cell. When the virus is inside the cell, the virus will want to break into the nucleus. But the virus doesn't have any legs or wings to travel. So how could it reach the nucleus? There's a kind of protein that's called motor protein. The virus will trick the motor protein into believing that it is something useful. Then, the motor protein will transport the virus to the nucleus. And this will be the second time the virus tricks us. It made us help the virus to transport to the nucleus. While the motor protein is dragging the virus, the shell of the virus will start to crack bit by bit. And by the time the virus reaches the nucleus, the entire shell will be gone and the core of the virus will be fully exposed right in front of the nucleus. And this will be the third time the virus tricks us. It made us help to crack the shell for it. When the virus is inside the nucleus, the virus will trick the nucleus once again and make it believe that it is on the same team. Then, millions of copies of the virus will be reproduced like a photocopying machine. And this will be the fourth time that the virus tricks us. It made us help it to reproduce. When those millions of the copies burst out of our cell, they will spread to our different body parts. But if there are just millions of them, it will not be a problem to our body, because our body has over 100 trillion cells to fight them. Millions of the viruses is just a drop in the ocean most of the time. However, if this number grows bigger, it will become too late for our immune system to fight back, all because we couldn't recognize the virus early enough, all because the virus is the world's most brilliant spy, who can trick us not once, not twice, not thrice, but tricks us 4 times in a row, and penetrates all the way through our defense system. So is there a way to give our body a heads up, like putting up a poster of the wanted man on the wall and say, "Look out, this guy is dangerous. Get rid of it"? The answer is yes, and the answer is vaccine. A vaccine is a genetic blueprint of the important component of the virus, but not so threatening. But what does it mean by having the blueprint but not so threatening? Well, basically, it means that the vaccine has the same look as the virus, but it doesn't have the harm. So, a vaccine has the shell like the virus, has the spiky things like the virus, but the core of the virus, this core, is something it doesn't have. That's why the vaccine doesn't have the harm, like the virus. When we inject the virus-like vaccine into our body, special cells called the B cell and the T cell will be recruited to fight the virus. And while they are fighting the virus, they will also be recording the image of the virus, just like using a camera. After that, they will send the image to our brain. So the next time, when the same virus invades our body again, we will know how to fight the virus. So after a vaccine is invented by scientists and doctors, how could we get it into our hands? Actually, this process contains a number of checkpoints. The first step is the preclinical test. It involves experiments in the laboratory and with animals. Scientists must ensure that the vaccine candidate is not only effective and also safe. If the vaccine is imperfectly made, it may increase the danger and may even cause the person to die. When the vaccine achieves the potential results, it will go to the next stage, which is the clinical trials. It begins in a small group of people. If it passes a small group of people, it moves to a larger amount of people being tested with scientists and doctors, closely monitoring the safety of candidates. Upon the completion of successful clinical trials, the vaccine candidate will then be reviewed and approved by regulatory agency. After that, the vaccine will then be ready for mass production and will be distributed to people. Only after that, we will finally have the weapon we need to fight the virus. Now, let's consider our exams as the virus and ourselves as the immune system. The reason why we can't fight the virus well is because the viruses are new. Similarly, the reason why we can't do well in our exams is because the questions are new. So let's imagine this. What if we can have the exam papers beforehand? Then we can take it home, practice, and even find some help from our parents or tuition teachers. Figure out how to answer those questions correctly. Then when the actual exam day comes, wouldn't we be so ready that the exam will feel just like a piece of cake? Sadly, no. We can never get the exam paper in advance. But there's something we can do. We can work much more harder and we can get much more exposure. So we can experience many different questions and different viruses. And when the time arrives, no question or virus can surprise us anymore. My dear fellow conventions, let's work hard and get ourselves immune. If you have any comments about our presentation or have any health or sports related questions, please email us at sportsleaders@clementieprimary.edu.sg. Thank you and see you at work.